Okay, so good evening everyone. I hope everyone is fine. Today I'm here to discuss a little bit about anti-metabolites. Anti-metabolites are basically a class of anti-neoplastic drugs. As we know, anti-neoplastic drugs are the drugs which are used to treat cancer. So let us first discuss a little bit about what is cancer or tumor. So basically, tumor is a mass of lump of tissues that may resemble swelling, and not all tumors are cancerous, but it is best advised that whenever you find any kind of swelling in your body which can resemble to that of tumor, we are advised to consult a doctor. So if we try to see the exact definition of tumor, it is said that it is an abnormal mass of tissue that results when cell divides more than they should, or they don't die when they should. So it is a definition given by the National Cancer Institute. So this is all about tumors. So tumors are again classified into two classes. In some of the books or some of the journals, you'll find they are classified into three classes, but benign, pre-malignant and malignant. But in general, they are considered into two classes, that is benign tumor and malignant tumor. So benign tumor are generally non-cancerous. They are either cannot spread or grow very slowly. So they are not generally represented as considered as cancerous, but they can be serious in the cases if they are depending on the location of the body where they occur. Like if they are occurring in some of the parts where they are pressing the some major arteries or veins, so that can be dangerous, or they sometimes can occur in brain matters. So those kind of benign tumors can be serious, but then again they are not cancerous, so they respond very well to treatment. So once they are removed by surgery or use of medication, can possibly treat them. So the second class can be said as pre-malignant tumors. Sometimes they are also considered under the benign tumor, that is, they have pre-malignant tumors are those that they have the potential to be malignant in future. So those are considered as pre-malignant tumors. And the third class is the main concern of our subject, is the malignant tumor. So most of the malignant tumors malignant tumors are in general, they are considered as cancerous. This type of tumors have the ability to grow uncontrollably and metastasize to various parts of the body, and can invade surrounding tissues also. So this kind of tumors are generally considered as very serious, and treatment is advised as soon as possible. So from the little bit of discussion about tumors, it can be said that only malignant tumors are cancerous. So any tumors which are malignant in nature are said to be cancer. So again, cancer or the malignant tumors are again divided into 5 different classes depending upon the type of cell they are occurring. Like the first class include carcinoma. So this class of tumors or malignant tumors are derived from epithelial cells, that is, they can be found in breast or in lungs or in the colon or in the pancreas. And the second class is sarcoma. These types of malignant tumors arises from connective tissues. These tissues includes these tumors are made of cartilage or fats or nerves, can be said. And the third class includes leukemia and lymphoma. So these are malignant tumors tumors arises from cell that makes the blood. So these tumors are found either in the lymph node or blood, and leukemia is in general found in children. And the fourth class includes germ cell tumor. So it is derived from germ cell. From the name itself it can be identified it is derived from germ cell, and it is generally occurs in testicles and in the ovary. And the last class of tumors include blastoma, or the last type of cancer include blastoma, the fifth class. So it is common in children. It is a tumor that resembles an immature or embryonic tissue. Some of the examples are nephroblastoma or medulloblastoma. So this was about cancers, the different types, and now let's discuss a little bit about how cancer is caused, or the causes of cancer. So the first cause of cancer is exposure to carcinogenic hydrocarbons or excessive radiation. Second class includes hereditary factors, that is from your previous generation, which is passed on to the next generation. Most of the times this includes chromosomal abnormality or immune defense system or hormonal imbalance. The next factor is the cultural factors, and it is one of the most important factor which causes cancer, and it is about 70% of the cancers which are caused are because of this cultural factor. So these cultural factors include like life habit, various life habits, which can include diet or smoking or sexual habits. Another one class which can be considered, or another one factor which can be considered causing cancer is occupational factors, like and the people are working in industries or factories which have more exposure to ionizing radiations and chemicals and other carcinogenic substance. So this was about the various causes of cancer, and now how cancer can be treated. So cancer can be treated by many of the different treatments, but although it is in general considered that all cancers can't be treated, but depending upon the stage of cancer and the correct choice of medication, cancer can be treated. So the various types of treatment available are chemotherapy, surgery, radiation therapy, and use of anti-neoplastic agents. So basically anti-neoplastic agents are specialized drugs which are used to treat cancers. Specialized drugs used to treat cancers. These are the drugs that can be used alone or in combination to other anti-neoplastic drugs. These drugs destroys the cancer cell obviously, but they have some serious side effects which includes nausea, hair loss, and mouth ulcers, and lowering of blood cells. Now, so this was about anti-neoplastic drugs. Anti-neoplastic drugs, in simple words, if you can say, these are the various kinds of chemical substance or drugs which are used to treat or to destroy the cancer cells in our body. So the next is what we'll go through is classification of anti-neoplastic drugs. So anti-neoplastic drugs are again divided into various classes. The first class includes anti-metabolites. So this was the actual chapter which we are going to discuss, as the other chapters we have discussed in the main in our classroom. So anti-metabolites are again subdivided into folic acid antagonist or purine antagonist and pyrimidine antagonist. So in simple words, it can be said that anti-metabolites are similar substance or which resemble to the metabolites used in the cell growth. The second class includes alkylating agents. So again they are again subdivided into nitrogen mustard. Example of some nitrogen mustard are mechlorethamine, mephalan, chlorombucil. Then nitrosourea, again another one subclass of alkylating agents, which includes cormustine. The third subclass of alkylating agents is aziridine. So aziridine, the example includes thiotepa, benzotepa, Another one subclass is aryl sulfonates, example is busulfan, and this was the various subclasses of alkylating agents. And the third class of antineoplastic drugs is antibiotics. Now again, antibiotics are again divided into two classes. One is anthracyclines. So the examples are doxobucin and durambucin. And another one, miscellaneous antibiotics. So various types of miscellaneous antibiotics are used, like actinomycin, neomycin. Plant products are also used as antineoplastic drugs. So these are again one class of antineoplastic drugs. This includes vincristine and vinblastine. The fifth class of antineoplastic drug is hormones and their antagonists. So example is ethinyl estradiol or ostradiol. Some of the miscellaneous chemical, another the sixth class which are generally considered, sixth class is miscellaneous antineoplastic drugs. So this includes cisplatin, hydroxyurea. So basically antineoplastic drugs are classified based on their mechanism of action, so how they work, so or the how they are going to affect the body. So now we are coming to our main chapter, which is anti-metabolites. So anti-metabolites are the class of drugs that replaces or inhibits specific metabolites of a cell. They interfere with the normal cellular metabolic functions. In other words, anti-metabolites prevents the biosynthesis or utilization of normal cellular metabolites. So anti-metabolites is similar in structure to that of a metabolite, and so readily gets as they are similar in structure, so they readily gets incorporated into the DNA or RNA and interfere with the cellular functions. So as we have already said, they have subclasses. The first class is folic acid analog. So folic acid is a group of drugs. Folic acid is a group of drugs which structurally resemble folic acid. So the folic acid get reduced into tetrahydrofolate. In general, folic acid reduced into tetrahydrofolate factor, or THF, by the enzyme dihydroreductase, or DHFR. So the tetrahydrofolate factor is necessary for the synthesis of purines and amides. So folic acid antagonists like methotrexate, they inhibits DHFR, that is dihydrofolic reductase, which in turn leads to the depletion of folic acid in the cell, folic acid cofactor in the cell, and thereby prevents the biosynthesis of DNA and RNA in the cancerous cells. Now, as I have provided the notes in the Google Classroom, there will find the synthesis of methotrexate. So it is an example of folic acid antagonist. So it is synthesized from so the synthesis structural representation of the synthesis of methotrexate is given already in the notes uploaded in the Google Classroom. And the second subclass of antimetabolites is purine analogs. So purine analogs are again structurally resembling to purine. So purine structure containing analogs, and some of the examples are mercaptopurine, thioguanine, and thiopurine. So the nucleosides of purine analogs are cytotoxic acid and acts as prodrugs. So the antineoplastic activity of purine analog depend upon the relative rate of enzymatic reduction or and inactivation of the compound in various tissues and cells. Now again the synthesis synthesis of one of the example of purine analog, that is mercaptopurine, is again provided in the Google Classroom notes that I have given in the Google Classroom. So mercaptopurine, it is synthesized basically from hypoxanthine. So the mechanism of action of purine analog includes mechanism of action includes so in basically it competes with the purine derivatives and it gets converted into 6-monophosphate as thiomonophosphate by HGPRT enzyme, which inhibits the conversion of thyrosin and thyroxinic acid and adenylic acid, and thereby prevents the biosynthesis of the cancerous cell. So this was about the antimetabolites. The synthetic scheme have to be shown in pen and paper with structural representation, so I have given it already in the note provided in the Google Classroom. So for now, thank you, good night.